Now, when you go in and attack proofs, what you don't want to do is just start writing stuff down. You know, you got to have an idea in your head of what you want to do in the proof. So get a plan together. All right, on those other ones, they kind of got a plan for you. You know, sometimes it's okay to just go for those. But when you've got to come up with both sides, want a plan. So let's plan our attack first. We are given RT and RV. We are also given NT and NV, and they want us to prove TS and VS right here. Now what you'll notice is we have a whole bunch of information for these two little triangles right here, but TS and VS are not part of them. So my idea is going to be, well, how do I get this big one congruent? I've got this side, I need this angle. How do I get that angle? Because once I prove the big one's congruent, I can CP/CTC the side that I want. I'm very close to having these little triangles congruent. All I need to do is get a reflexive on that third side, and I've got these little congruent. And then I can CP/CTC this angle. Once I get that angle, RS is reflexive, SAS the big triangles, and then I can CP/CTC that side that I want. That's a lot of C's. Anyway, so that's the plan. We got our plan together. Let's attack. I'm gonna throw in my givens. RT is congruent to RV, and NT is congruent to NV. That's going to be given. And then I want to reflexive that bad boy, so I'm going to get RN is congruent. Now how's it going to go? It's going to go NT this way, and then it's going to go, yeah, that's coming back the same way, so I can just do RN. I'm not going to lie to you, that order is not going to bother me too much. Anywho, reflexive. And now I've got my two little triangles congruent. So this order, very important. We're gonna go R N T, and it's gonna be congruent to R N V, and that's gonna be side side side. Now I'm gonna CP/CTC the angle that I want. So angle 1 is congruent to angle 2. Why is that true? Well, I proved the two triangles congruent, and those are corresponding parts. Then I'm going to want to take and get my big leg. So I'm going to go RS is congruent to RS, reflexive. And that will give me my two big ones. So RST is congruent to RSV. And that's going to be angle side. Now I got my two big ones congruent, and I can CP/CTC the side that I wanted in the first place. So TS is congruent to VS, CP/CTC. Cha-cha. Alright. Next one. Given 1 and 2, 3 and 4, prove that TU and some other one, TU and TW are the same. Now, this one is deceptive. Once they give you angle 3 and angle 4, angle 1 and angle 2, it should hurt a little bit how obvious that they are giving you enough information for these little ones right here. Alright, you've got enough information for those. Because all I have to do, just like the last time, is grab that piece in the middle, and now I've got those. What I want though for TU and TW is I want the big one. This is almost the exact same proof. You're just going to use ASA and then get the big one. You're going to go SAS, CP/CTC that side right here. You're going to have to CP/CTC this side, and then you attack. So very similar. When you see them start lighting up one part of the triangle or one set of triangles, just go for it. Just go for it in your plan. So I've got my plan. Get these two triangles congruent, these two little ones. Use this leg, and then I can get the two big ones done. It's going to be an easy one. So I've got 1 is congruent to 2, 3 is congruent to 4. That's going to be given. And then once I get that done, I need that side. I'm going to say SV is congruent to SV. That's going to be reflexive. And then that gives me my two little triangles in there. So SVU, make sure I have a difference between my V and my U, is congruent to SVW. That's going to be angle side angle. Then I have to CPCTC that one leg. VU is congruent to VW. CPCTC. And then I need to reflexive that middle line. So VT congruent to VT. Reflexive. At that point, I'm ready for my big ones. I've got the SAS. So I'm going to go TVW, and it's going to be congruent to TVU. And that's going to be SAS. Got that long side. Angle 4 and 3 are already proved, and then I CPCTC the side that I wanted. Once I have that, and TU is another leg of that triangle, so TU and TW are going to be congruent. They are corresponding parts of those two congruent triangles. Cha-cha. All right, looking good so far. All right, given the PR bisects SPT, where's SPT? So PR bisects, we're going to use that, and it's going to give us 1 and 2. And then PR bisects SRT, skadoosh, prove that PR bisects SQT. Now again, this is one of those times, look what they've given us. Given us all the information we need for the big triangle. I've got a side that they share, and I've got 2 angles. That gives me this big one for free. Why is that important? When we look at 3 and 4, we want them to be congruent. If they are congruent, it's going to mean that they bisect this angle. That this RPR right here bisects this SQT angle. So we want 3 and 4 to be congruent. If I can make the big triangle congruent, then I can CPCTC this side. That side plus a reflexive, this middle side is shared, gives me side angle side congruency for my little triangles. I can then, from the little triangles, CPCTC 3 and 4, and at that point, I'm done, ready to go. So let's attack this problem. I'm going to get my bisects out of the way. PR bisects angle SPT and angle SRT, and that's given. I'm then going to say that angle 5 is congruent to angle 6, angle 1 is congruent to angle 2, and that's going to be definition of bisector. Then I need my middle line, and that'll give me my big triangle. So PR is going to be congruent to PR. Reflexive. And now I have my big triangle. Did I spell reflexive? Reflexive. I think I got an extra E on there. My bad. Alright, now, continuing onward. That gives me my big triangle. So I have R, P, S, and it's going to be congruent to R, P, T, big triangle, and ASA. So angle 5, side, angle 1, ASA. Then I need to CPCTC that side. So I have RS is congruent to RT, CPCTC. And then I'm going to also grab this line right here. So I'm going to have RQ is congruent to RQ. And that gives me the 2 S's I need to get that triangle congruent. That's going to be reflexive. Here's my 2 little triangles. RSQ is going to be congruent to RTQ, SAS. And then finally, CPCTC 3 and 4, angle 3 is congruent to angle 4, CPCTC. And why did we want all of that? Because PR now bisects SQT, definition of bisector. Created 2 congruent angles. Looking good. Last 2 coming up.